Lissa Productions.
Welcome to Electronics Lab. Today we're going to be going over the basic equipment that we'll use throughout the semester. The first thing we'll talk about is the lab manual, which hopefully you brought with you. This has all of the labs that we'll be doing in here, and you pretty much can't do the labs without these. It also has a number of appendices at the back. One of these describes how components are labeled. Another one tells you about the proto board, tells you about doing fitting for data, and also there's an appendix that gives a sample of what we expect for a lab report. Another important thing, which you should have picked up on the way in, is your lab kit here. This plastic box, we'll open it up. It has various useful things in it. Set it down here. So perhaps the most useful thing in here is the proto board, which is the thing we'll be using to build circuits on. There are also some probes in here. I call these pokey probes. They let you measure voltages at various points on the circuit. We'll talk about those in a little bit. And you probably also have a bunch of jumper cables in here, or jumper wires, which are basically little pieces of wire that are stripped at both ends that we use to make connections on the proto board. The other thing we have that you'll find at your lab station is the DC power supply. We'll talk about this in a minute, but this is how we're going to be providing voltage to the circuits, voltage and current. The last thing you should find at your lab station is a multimeter that allows us to measure voltage, current, and various other things. And we'll come back and talk about setting all of these components up in a second here, but this is the basic equipment you should find at your lab station. We have here the proto board that we're building circuits on. If you look at this, you can see there's a number of places where we can connect wires to. Perhaps the most obvious are these round banana jacks here. There's 3 of them. And they can basically, we're able to take a banana plug it into there and connect that to some other supply. And so we can bring voltage into this proto board here. The other thing are the connections on the board itself. And we're going to start with these lines across the top here, which we refer to as buses. This top row here, all of these are connected together. There's a gap in the middle, then these are connected together. That repeats itself on the next row down, so these are all connected together. A gap, these are connected together. And it repeats it on the bottom again. So the bottommost row, the same thing, here, gap, and so forth. So we have 4 of these buses with breaks in the middle. The other thing we have are these connectors along the side. This row of 5 connectors here, these 5 are connected together. There's a gap, and then these 5 are connected together. And that repeats itself all the way across the board here. So that's the basic configuration of this board here. If you look in the appendix of your lab menu, you can see that described as well. Generally, we bring voltage into these banana jacks and then jumper it onto the board. There aren't actually any connections between these banana jacks and the board. So what I'm going to have to do is I'm going to get a couple of jumper cables here, and I'm going to unscrew this, and we can tilt it up, unscrew it, and there's a small hole here that we can now slide the end of the jumper wire through, tighten this back down, and then we'll take this wire and we will connect it into one of the buses here. So now whatever's connected here comes through this wire and goes to that bus there. We'll do the same thing with one of the red connectors. So we'll take this one here, we'll unscrew it so we can see the little hole in there. We slip the jumper wire in, tighten that back down, and we'll bring that onto the proto board on this bus here. So now the black one is connected to this bus over here. The middle red one is connected to this bus here. And if we bring voltage in through a pair of banana plugs to these from some voltage supply, say we have the black one is grounded, the red one is plus 5 volts, then we'll have plus 5 volts here, and that will be grounded. So that's how we'll hook up this proto board here. And here we have the DC power supply that we're going to be using throughout this course. It's actually 2 DC power supplies. One with controls here, outputs here, the other with controls here and outputs here. It goes from 0 to 30 volts. We can turn it on here, and we can adjust the voltage. So I can turn the voltage up, and you can see the voltage being read here. So there's something like 8 volts, 11 volts, and so forth. There's also a knob labeled current, and we'll come back to this in lab 1, but it doesn't actually set the current, it limits the current. So right now it's turned all the way up, so there's no limit on the current. For various situations, you may want to turn it down and limit the current. The same thing repeats itself over here with this other supply. This little button here, when it is out, it allows us to read the voltage. When it's pressed in, this reads the current. And we'll talk about the current more in the next lab. So when we want to hook this up to some circuit, We use our banana cables. The black cable and the red cable go here, and then this just takes the power to our proto board. We have here the multimeter that we'll be using through this course to measure DC voltage, DC current, AC voltage, AC current, resistances, capacitors, transistors, and various things. It's a very useful device, and we're going to set up in the first lab just to measure voltage and current. We'll start by turning it on. It's right now set on a 20-volt DC scale, so it's measuring DC voltage. To do that, we need to bring in that voltage. So we bring in ground, we put it into the common. We bring in some positive voltage, we put it here. And as that voltage is adjusted, you can see we start reading the voltage on the meter there. There's 4.4 volts, 5.6 volts, and so forth. So we can read the DC voltage with that on this particular scale here. The other thing we can do with this is we can measure current. So the current is measured with the common and the 20 amp or the 1 amp scale. We click this around to measure current. So I'm going to put it on the 20 amp scale. We bring the current in we want to measure. So the common, I'm going to start on the 20 amp scale here. We turn this on, and we can see basically no current. I'll start turning up some voltage somewhere, and we'll see there's very small current here. So why did I start on the 20 amp scale? There's actually a much finer scale, but inside of this current meter here, we have to run the current through it. There is a fuse to protect this device. If you run too much current through, we could burn out the components. We don't want to do that. If we were to do that, unfortunately, we would have to turn it over, unscrew the back, pry the back off, pry the fuse out, and replace it. And that's not something we normally want to do. So we start everything on the 20 amp scale. And when we see that we basically have no current reading on the 20 amp scale, then we shift this over to the amp, and we go down to the next scale, which is 200 milliamps. And then as we start to turn up the current, you can see here we have a few milliamps of current. There's 4.2, 8 milliamps, 10 milliamps, and so forth. So always start on the 20 amp scale to protect the device, and then settle down to a smaller scale to make your actual measurements. The other meter we have in this course is the so-called LCR meter, which allows us to measure very accurately the values of components. You want to do that because you really don't know what's in the box that's labeled a kilo ohm. You don't know what somebody put in there, so you just want to have a valid measurement of everything. So I'm going to measure a resistor here. I'm going to set the LCR meter into the resistor scale. It came out of a 1 kilo ohm box. I'll set it on the 2 kilo ohm scale. I'll turn it on by going all the way over to the LCR, put the resistor in there. On the 2 kilo ohm scale, it's measuring 0.999, and there's 1.00, so it's measuring 1 kilo ohm. So that's the resistance here, and in fact that box was then accurately labeled. So we have here the pokey probes that are very useful for going in and measuring voltages at points in a circuit. I've got basically a circuit with a couple of resistors hooked up to an external voltage source, and the pokey probes are hooked up to our DVM 20 volt scale, and I can go in and I can touch various places in the circuit. You can see between those 2 points it's 10.6 volts, between those two it's 5.3, between those two it's also about 5.3. So they're very convenient for going in and quickly measuring voltages between points on the circuit. They're not very useful as a permanent connection, but if you want to check something, they're really convenient. So we just go back over the equipment that we're going to be using throughout the semester here. We have the proto board, and here we have some simple circuit set up with some resistors. We have a DC power supply that's connected to the proto board here. Jumper wires bring the voltage onto the board. And we've got a voltmeter and a current meter hooked up measuring voltage and current at various points on this board. Voltage is measured across components. Current actually has to run through the meter to measure it. And lastly, we have the LCR meter here, which allows us to measure the values of components, and we can record that in our lab book. So this is all the equipment we have. Read your lab, and you should be familiar with this. And you'll see this in the lab, and hopefully everything will be familiar when you start working with it.